My name is Yasin, and I'm a student, right? I'm a student who is pretending to be like a lecturer, but at the same time not a lecturer, but claims to be better than a lecturer. Anyways, not the point. Point is, this is the first video of system analysis and design, and I'm gonna try to finish the whole syllabus in like system analysis and design. Long section, but I'm explaining it in a student's perspective. Okay, so starting off, what is system analysis and design? So if you picture a workplace, right, and let's say if the whole workplace wants a system in place, so maybe if you can picture like a website or like some system to help them work. For example, if you want a transaction processing system, so the whole workplace links to this whole system of programs where it helps with people coming in, customers coming in, ordering your online business. So this whole thing over here goes through so many steps of like basically taking this design and putting it into action and getting a whole system out of it. So that was the whole thing is about. So let's go to the starting point. Um, let's see. There's so much of yapping over here. Okay, so it starts right there. We go. So how a new system development in project is initiated? How is a system development started? So firstly, a system is a group of programs together, right? So programs, is code, right? So when you have different type of codes that are programs all together, it creates a system. A system is designed to do something. Example, if you have a system that records sales in a business, that system is for a purpose to record the sale of the business, right? It consists of so many programs that help make the system. Now, when to start developing a project, right? When do you want to now develop a new system? So obviously, when the business wants to develop a new system, it may have a problem. So now to prevent this problem or to stop this problem, it might develop a new system. Also, it's a growth strategy. So like sometimes people will want to develop these systems because they want to become more like dominant in the market or basically make more sales, right? If you're a business and if you want a whole system to do your online store, you're going to use a new system, so obviously you can make more profit at the end of the day, right? M-commerce is like your online store, mobile commerce. So going down quote, hey, they have quotes over here, man. The overall objective of a system development is to achieve a business goals, not technical goals. Now, I might be thinking, what on the earth is a Shakespeare Miggy thingy? Listen here. Basically, they're saying the overall objective of a system is to achieve business goals but not technical goals. So, what this means is it mustn't be a good system. Like, don't develop a system because it's good. Rather, it must address a specific issue. So, like example, if you order like a very expensive system, but this system doesn't do good to your business, like doesn't benefit you so much, but it's an expensive system, compared to if you buy a cheaper system, but it addresses your specific need for the system better, right? So yeah, that's what basically it means, right? So information system planning. Now, don't get develop. So information system planning is just like a very small concept, a narrow concept. It's basically seeing how like an information system can be planned, right? So information system is obviously it's a very small thing. So like if you want like a computer based system, these are the steps. So plan for the business, develop overall objective, identify the project, set priorities, analyze resource requirements, set schedules and deadlines, develop information system planning. This is really not that important, right? But yeah, just know it. Okay, who is involved in system development? Now, this is where the main part is system development. That is what this whole section is about. So, when you want to develop this whole system in the business, who's in charge or who takes part in it? The keyword is everyone, literally. You got the users over here, the users, these are us, right? Then you got the managers, then we got the software programmers, then we got the technical specialists, so suppliers. So everyone takes part in this process of developing this whole system. Now, who's this over here? Who's the smarty over here? Let's call this girl Amy. So who's Amy over there? Amy is a system analysis. Now, I might think, what on earth is a system analysis? Now, to develop this whole program or software or this whole system, you need something called role a software analysis. So wait, what is it called again? System analysis. Sorry, system analysis. So the system analysis, what does it do? The system analysis, what she does or he does, is basically goes to everyone in the business, the customers, the suppliers, and looks at what the needs are for the system. So you have to create this whole system in the business, but you need to know what system to create. So you do this by going to the suppliers, the customers, the employees, the managers, the owners, and asking them what are the needs of the system. Now, another need for the system analysis, in simpler terms, is an architect. So, you know how an architect develops a building? He doesn't build a building, he develops a drawing of a building. Same thing for system analysis. What they will do is they will design the the blueprint or the architecture of the what's this called, the system, right? So how the system will work, how the system will produce stuff, right? Input, output, all that. So it'll plan the design. They won't make it, like, they won't make the system. Don't get it wrong. They won't make the system. They're like an architect. They will draw out what the system will look like. They will then take the system, draw out or like what it needs and all that, and then go to like the programmers and all and convey the information to them. So that's how you know what a system analysis is, right? So a system analysis should have all knowledge, right? You can't just be there in the business with no knowledge. You have to have all these knowledges of hardware, software, communication, and so on, right? The system development lifecycle, extremely, extremely important. So from now on, right down, we're gonna develop this life cycle, right? Now there's 5 steps in this life cycle. So now as you're gonna learn it, we'll discuss the first step, which is gonna be so long. Second step gonna be so long, but basically we're discussing each step now as we go forward now, right? So what are the 5 steps, right? There we go. First step over here is investigation, right? Now what is investigation? You need to find out what is the problem, right? What is the problem? That's the most important part. What is the problem? And is it worth solving? This is very important because sometimes problems, it's not worth solving. For example, in a whole business, like let's say take a lot, if there's a small problem where, let's say, one item in like the shopping, the whole store is glitching, is it worth spending R1 million to fix a problem? No. So you won't pursue this whole system thing, life cycle. But if it's worth solving, it's a big issue and you have to solve it, then you do it. That's what investigation is, eh? Now we learned something just now called a feasible analysis, where we'll look at this analysis and see whether it will like be worth it to actually do this project. Now the second one is analysis. Now what is analysis? Analysis, you must look at what things you need now for the system, right, to solve this problem. Basically, you will look at the needs of the new system. So now you know you're making a system. So analysis stage, you'll say, okay, what things I need for this new system. You'll also look at the existing system in the business and see how it operates, right? So here in the analysis, you basically like, okay, I know I'm putting this new system in place, but now I have to see that, listen here, how do I now make this whole new system? And if you look at the needs of this new system, okay, then you get design. Design is very easy. You design the system, right? You look at what the actual things you need in the system. So you look at how to obtain the system, right? You need to design. Now when you design this, you're going to look at different ways to design it. For example, the literal system, must it be like a menu based system? Must it be a command based system? So you looking at the system right now and designing it such a way to like actually make the system, right? Now implementation, right? Implementation is very important. This is where you actually put the system in the business. So where you prepare the system, right? You implement the system. You train your employees on the system. This is where the system is literally being in there, prepared right now, in there, existed. So installed, where the system is being used, implementation, you're implementing the business. Last one, maintenance and review. So maintenance and review, operation maintenance and review. Basically, this is when it's done. Keyword done. You make sure the system is doing well. You make sure the system is doing what it has been thought to do. So what is expected thing you so example if a system's supposed to record sales, now you look at it whether it's recording sales correctly. That's the system review, right? Mm, so let's move on. Now the waterfall system development cycles. Okay, so you see this whole 5 steps over here? This is called a life cycle, right? But this life cycle can vary. Like there's different types of those life cycle. But don't get so confused. It's not that confusing, yeah? So what is the definition of requirement? Is a list of things that a system must do, right? What is required to do? It's simple. Okay. So the first variation of this whole 5 steps is something called the waterfall. Now I'll explain to you what waterfall does, huh? The first step, investigate, you will do. After you do this whole step, you will stand here and you'll be like, I'm done with this step. Now let me go to this step. We'll do this step, and then you're done. Then you'll go over here, do this step. So can you see how I'm completing one step and I'm not going back to it? I'm fully completing that step and going forward. Each phase is completely total for starting the next. Huh? This is also called a traditional approach. This is the actual 5 steps we study. It's called the waterfall approach. Huh? However, what is the so this is the traditional approach. So obviously now if you're gonna do this whole thing and go back here, you can't go back. So if there's a problem with the waterfall approach, you can't go back. But then you get something called a modified waterfall approach where you can go back. So although you finished whatever this step is and you go over here and now you're completing over here, you can go back. So you can actually run and go back to the previous stage. But the problem is, well, you can modify it waterfall. That's a key word here. You can go back. Can go back. But the problem is it's going to be a lot of cost, right? So modify waterfall. See, as you're going, you can go back. If you couldn't go back, there wouldn't be these arrows here. It'll just be going down. That's the waterfall. But modified waterfall, you can go back, right? Now, as you can see, with the modified waterfall, it's going to be a problem. When you go back to the previous stages, you're going to have a lot of costs involved, right? Just change now what you did. Because what you must see over here, the earlier the stages, the lesser the cost. So if you make a mistake in the implementation stage, the cost is very, very high. Then if you made a mistake over here, no worries. It's gonna cost you very less. But if you made a mistake like over here, it's gonna be very expensive to like go to the other steps, right? To travel to the other steps. So you can't do it, but it's gonna be very, very expensive. So you just rather commit suicide because the business is gonna kill you, fire you. Yeah. Okay. So now the traditional SDLC. So this whole 5 steps are traditional. This is where you completely, fully complete one stage, go to the next, and do not go back. So formal review at the end of each stage allow for maximum control. Approach. Okay, so you can read all this, huh? But basically, it's a very, very good approach, right? To do. But the problem is you can't go back if there's mistakes. That is what this whole thing summarizes. Real life example. So as you can see, NASA is supposed to be over here. This is supposed to be the graph of NASA. But NASA made some stupid mistakes in his life. I don't know why they're planning to go to space to Mars, to be honest with you. Signs of life of Mars. I fully believe that there were signs of life in Mars, but a meteor came and hit. Okay, this is IT. Sorry. Anyways, they're supposed to be in this line here. But now, because they happened over here to make mistakes, they went up, right, in cost, right? So when you make a mistake while you're doing this whole 5 step process, it's going to be expensive. So don't make mistakes in life. Okay, other system development cycles. So besides our 5 step approach, there's also different approaches. It's called prototyping. My favorite, prototyping. Prototyping. Now, if you want to develop a system in a business, and if you don't want to do the 5 steps, there's something called prototyping. Prototyping is very, very smart. So you'll develop a prototype. Now, what is a prototype? So let's say this whole big system is so big, right? But you need to see if this whole big system will work properly. But you don't want to build this whole system. So this whole system is very, very big, right? So a prototype, you build like a small miniature type of system. So you build a small system that is very, very similar to this big system, but you use the system, right? And you test it that if it's working properly. So it's a similar system to the big system, but it's smaller version, right? Now, the small system over here, you will have all your employees check if it's good, your customers check if it's good, and they give feedback. So let's say one customer says that, listen here, you're stupid, make it more better, make it more colorful. You'll take this and you'll make it more colorful, you'll get this prototype. Prototype 2. It's called iteration. Iteration means repeat. Repeat 1, repeat 2, repeat 3. So my first prototype was 1. My second prototype is 2. This is iteration 2. And then now the manager said, he swayed you in the workplace, said the system, it's very, very stupid. So now you create a more better system. You over here, iteration 3. So you keep repeating it until all your advice from all the people tell you what to make the system. So you keep improving the system until the system becomes your system in the business. That's prototyping, right? So you keep making this whole system, modifying it, changing it, creating a new system, modifying it, changing, creating a new system until you get the system. That's prototyping. So you design, you implement, design, implement, design, implement. Sorry, analyze, design, implement, right? Yeah, analyze, design, implement. Now, as you can see over here, same thing I just discussed, iteration 1 and iteration 2. Split it up. So you created this whole prototype, but now someone wants something else in the prototype. You make it and you do the whole thing again. You make it, you do the whole thing again. You make it, and the final one is the last one. Yeah, you can read this. Basically, the prototype, the advantages is it takes less time. Also, it's very, very good because at each stage you're like basically making it better. Right? Disadvantages, it takes too long, right? The final solution, people would just want to be better, 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 but then it'll keep repeating, making it better, 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 but there won't be a final product or final system because people always want things better. Um, okay, so there's other system DLC development steps. So we got those 5 steps, which is the traditional approach, which also called the waterfall method. Then we learned the waterfall modified method. Then we learned the prototype method. Then we learned RAD. Now what is RAD? RAD is rapid. So if you want to create a whole system very, very quickly, very, very quick, you do something called a RAD system. So employees use tools, method, design. So this whole employees in the business or you hire people, right? They basically create this big system very, very quickly, right? They do this by something called joint development. So joint development is part of RAD, right? Don't get confused. So joint development means you basically get involved like the people in the business joint development, like different departments, the manager, and you create this project, right? So very, very quickly you do it. Um let's see. Yeah, so it's also called group support systems and software. You get a lot of people to do it, right? Yeah, you can read that. Another system under RAD is called Agile. So Agile is split into two again. You got the Agile development extreme programming. This is where it's like this project you got, a system you got needs a lot of programming coding. So you get a lot of code people together. So like example, you get 2 people that are good at coding, and they work at this project fast together. That's extreme Agile develop extreme programming, huh? And then the other one is normal Agile. Where's the normal Agile? Oh yeah, normal Agile. So the develop people who's making the software system, they will interview like people, the employees of the business, to develop the system. But what most important thing is they're working with a lot of people, right, in pairs and all that. That is rapid. This whole rapid thing, they're working with a lot of people together to make the system work very, very fast. Factors affecting system development success. So there's a lot of things that prevent systems from developing. So involvement from users, obviously the more involvement from users the better. Top management support, degree of change required. So basically you need managers, employees all to support the system, right? They must encourage you to make the system and so on. Degree of change. Very important. What's the difference between continuous improvement and business process re-engineering? Now if you did business studies in school, this will be very easy for you. Continuous improvement is when you want to make a change in the business that's very, very small. So let's say if you want to change the color of the walls in the business, that's continuous improvement. Business process engineering is a change that is very, very big. So let's say you want to kill the manager. I'm just joking. I'm just joking. I'm just joking. I'm not joking. I'm just joking. But basically, it's a very, very big. Let's say you have been manufacturing chocolate all this time, and now somebody comes and walks there. He woke up from the wrong side of the bed, and he said he wants to manufacture chicken heads. So now his whole system has to change in the business. So that's a big improvement. Therefore, business process engineering. So you can read that, and yeah, that's it for the first. Yeah, it's actually taking long to do this topic. I'm just realizing now because this is the first slide out of 9. But yeah, that's it for this slide or this part or whatever you want to call it.